When we hold Geography 2050 every November in New York, the lightning talks are some of the most popular presentations of the symposium. Today we have 4 for you, 2 right now and 2 a bit later. The presenters are underneath a lot of pressure. They have 20 slides and 5 minutes, but they are not in control of their slides. They are automatically being forwarded every 15 seconds, so there is no room for error like the problem that I had earlier. To start us off is Dr. Allan Trapp, who is going to talk to us about empowering ESG efforts with geospatial agility.
Hello everybody, my name is Allan. I like numbers, and I'm going to talk about feet. Well, I'm inclusive. I'm going to talk about baby feet, like farmers, and I'm going to talk about big feet, or adult feet, like Enterprise's ExxonMobil. Particularly, we're going to be talking about how does this relate to this idea of greenhouse gases, because each cares about what this means to their environmental, social, and governmental goals that they've set. Now, if there's one thing you walk away from this conversation today, it is that this measurement process is very complex, and object computing has a way to measure this efficiently and quickly. But I'm going to aim for a little bit more. Number one, you'll know that enterprises are seeking something that's accurate and going to be useful for them. Number two, you're going to learn about the state-of-the-art model GREET. And then number three, we're going to be talking about a web-based application that makes this easy and consumable for anybody, not just farmers, but also enterprise, and how this relates to Google and AI. Now, in recent news, there's been this talk about renewable energies, particularly biofuel, and saying that it reduces greenhouse gas emissions. Well, it's not just about how it gets burned and how much greenhouse is emitted from that burning. It's a whole process when they talk about the reduction. It's this idea of farm to the customer. It's holistic. Now, the recent news says that these biofuels in soy actually are 80% reduction to conventional fuels. Pretty impressive. But you know, if you want to aim a little bit bigger and make that 20% lower, where would you go in this journey to make it lower? Well, on the farm actually can contribute up to 20% of that. And yes, that makes sense if you talk about equipment, but did you know that there are other factors like what's your crop rotation, what's your type of irrigation practice, or other things like cover crop that affect that? All in all, it's an end-to-end process, as I said, in that there's these last 2 steps of transportation you consider and refining. Now, how do we get to this is through this idea of a GREET model. This GREET model stands for greenhouse gases, regulated emissions, energy use, and transportation. Quite a mouthful. This is a state-of-the-art model from Agronomy National Labs that's used to estimate greenhouse gas emissions using various levels of geospatial data, whether it's state level resolution that is used in C Club, all the way down to the field level, which is used by this LMC model. All in all, we can make this really, really fast if we can get this data really quickly, like using satellite imageries or sensory data at a very high resolution, and getting to more accurate, more precise estimation of what that greenhouse gas actually is. Well, we did that. Welcome to GREET. This is the farmer tool that calculates carbon emissions, or more precisely, the greenhouse gas emissions. Now, how do you use this? You gotta know where's your field. You have to be able to define where is it that you're gonna be doing this calculation. It could be small, it could be big, and essentially, how much greenhouse gas are you going to be doing when you toggle all these switches around what is your farming management practices. Like I said earlier, it could be related to the cover crop all the way down to what is the nitrogen application you use. That's that configure growing season button right there. That's how this makes it happen. It's not just for one field. You can do this over multiple fields, or you could do this for multiple seasons. Now, this is an interpretable thing. How do we make it interpretable? If you're a farmer, you know what fertilizer is, you know what is your cover crop, you know what type of nitrogen fertilizer or what type of application will you be doing. This takes it to farmer land. That's the intent. It has to be useful. Behind the scenes, we have all this AI, and we have these satellite data that's coming in and feeding in addition to that to make it more personalized, so that you can test out different types of combinations to get to a smaller greenhouse gas footprint. You can see there for 2. That is the end of my presentation. I hope that you could walk away and understand that we can empower farmers with this application so they can see how changes to their management practices actually affect their carbon footprint. And then furthermore, it provides a carbon emissions data for enterprises to get to tracking to their sustainable goals. Thank you for your attention.
Thank you, Dr. Trapp. Perfect. And next in line is Mr. Peter Webb, who is going to discuss cultivating climate literacy, greenhouses as tools for understanding geography's role.
All right. Good afternoon, everyone. My name is Peter Webb. I'm the co-founder and CEO of MARSfarm Corporation. I was born and raised in St. Louis. I was homeschooled K through 12, and then actually went to UMSL, where I got my degree in business. Started MARSfarm in 2020. My co-founder, Drew Thomas. We're about 2 miles away from here in an area called Overland, where we manufacture and sell these countertop-sized little greenhouses that control climate. So climate's complex. Temperature and humidity are just 2 components. Another one's light. This larger map here shows you the daylight integral. So that's the cumulative amount of light that reaches a given area for all 12 months of the year. When we zoom in on St. Louis, we see that the DLI changes a lot over the course of a year. Down near the bottom, we've got leafy greens. Up at the top, fruits, things where we're getting further down the reproductive cycle, like a pepper, a cucumber, a tomato. It takes more light to make more calories. So this has a lot to do with where we end up producing our fruits and vegetables all across the United States. There's another big factor, though, in that, outside of just geography, and that is the plant itself and which part of it do we eat. So if we eat the leaves of a plant, yes, it might grow faster, and yes, it might require less light, but that also means it's going to spoil much faster. So what this creates is an opportunity in some crops. Take mustard or collard greens. 50% of those are thrown away by retailers in the United States. 50% of all of the product they put on their shelf, they throw away. So that's an opportunity for them to not do that if that food was grown much closer to them. That picture you're seeing is Wagenhagen in the Netherlands. Those are greenhouses, all producing the peppers you would get if you went to Schnucks right now. We, in the United States and all over the world, there's a great deal of focus on how do we maximize the light? You know, how do we get more out of the same amount of light? One way you can do that is by increasing the CO2, actually. So at about 1,000 parts per million of CO2, you can double the efficiency of a plant's growth rate. This is an industry that's fascinating to me, but I was just a kid. And so I found the world of open source software, hardware, and thankfully, online forums filled with makers, hackers, and biologists, where we could hack away developing little boxes, controlled environment greenhouses to grow plants. The idea was that if we could figure this out on a small scale, we could replay these recipes on a medium, say a shipping container farm at Maryville, or a much larger scale like AeroFarms. But how do we make this easy to access? So we developed a minimum viable product, and that means the cheapest example of a way to make a box that would have a computer control it, and it would grow plants. So for $300, we put these designs online, and about 500 people all around the world built those in less than a year. We found a lot of those people were teachers. They were schools, and these schools reached out to us and wanted to buy 10, 20 of those kits at a time. And that's when we created MARSfarm as a business. And now we focus on serving the market of agriculture education. The largest student organization in the United States is the Future Farmers of America. But ag tech hasn't made its way into ag ed. And that's where we see a real opportunity to modernize greenhouses, not with LEDs at scale, but with small, iterative versions of greenhouses. These are students that took 7th in the nation for the FFA Agri-Science Fair last year. They used 6 MARSfarms to compare whether it was better to have more intense lights for less time or less intense lights for more time. We work with citizen science programs that interpret the light settings used on the International Space Station so that we can mimic those and replay them in countertop-sized greenhouses all around the world. We're in about 500 schools right now, and this is a partnership we have with the Botanical Garden in Miami, Florida. And the data collected by the students, how well those plants did, that data is all used by NASA to determine which plants they'll then grow using those same light settings on the ISS. We've taken this further, and now we've added other controls, like irrigation and control of temperature, so that we can increase the temperature and have students in their elevated CO2 environments, which are classrooms, they can learn about plants in a way that is fast. When you see a GIF or a time lapse of a plant as a student, it becomes much more easy to understand how what you did 2 weeks ago had an impact. It's much harder to try to remember what happened last semester. And we think this is the way that not only as a business, but as an industry, we should move forward. That really by focusing on education and focusing on small iterative versions of growth chambers, we can then scale much larger and replay those recipes that we learned about by looking at the environment and climate and replay them on a large scale. Thank you so much.